All right, friends, here it is. This is the final free response question that I'm going to be recording for you all, at least for now. So here we go. This one again is for BC students. The amount of water, the amount of water in a storage tank measured in gallons is modeled by a continuous function on the time interval 0 less than or equal to t less than or equal to 7, where t is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank is given by f of t equals 100 t squared sine square root of t in gallons per hour on the time interval 0 to 7. The rate at which water leaves the tank is given by this piecewise function g of t is equal to 250 for the time interval 0 less than or equal to t less than 3, and 2000 for the time interval 3 less than or equal to t less than or equal to 7. I want to color code this. So this graph over here is f of t, and this is water entering. These two functions over here, these two pieces, represent g of t, and this is water leaving the tank. This is a pretty typical question. There are definitely some challenges here, but we've got two rates. We've got water going in, we've got water leaving. Let's see, what else do they tell us? The graphs of f of t and g of t intersect at 1.617 and 5.076. So this guy right here is t is 1.617. This point over here is t is 5.076, are shown in the figure above. At time t equals 0, the amount of water in the tank is 5,000 gallons. That's your initial value. They have given us a whole lot to think about in the opening to this problem. Part A. How many gallons of water enter the tank during the time interval 0 less than or equal to t less than or equal to 7? All that I'm interested in is how much enters the tank. I don't care about how much leaves the tank on this time interval. I'm not even interested in how much is in the tank in the beginning. I just want to know how much water enters the tank. Well, since f of t is the rate at which water is entering the tank, then what I need to do is find the integral from 0 to 7 of f of t dt. Again, this is a calculator active question. So let's go over to my calculator. Where is it? There you are. I've graphed the function f of x in this case. I'm going to go over to the calculate screen, menu, calculus, numerical integral. I'm integrating from 0 to 7. The function is f1 of x, and I'm integrating with respect to x. And I'm getting 8,263. Bummer. I'm not getting enough decimal accuracy here either. What is going on tonight? That means I need to go back over here to settings, to document settings. Float again. Fix 3. Make default. Okay. Let's go back over to calculate. I want to do that calculation again. There we go. That's more like it. 8,263.807 gallons. Now, I want to be careful because if you go back and read the question, it says round your answer to the nearest gallon. Well, the nearest gallon for 8,263.807 is going to be 8,264 gallons. Let's go back to my notes. The way we awarded a point, 1 point for the definite integral, 1 point for the 8,264 gallons. You had to round, and that got you 2 points. Not too bad. I would expect most students to earn these points. Now let's look at part B. Part B, for the time interval 0 less than or equal to t less than or equal to 7, find the intervals during which the amount of water in the tank is decreasing. Give a reason for your answer. Okay, let me scoot this up. I really need to look at the graph. I need to know when is the water decreasing. Well, what would have to be true for the water level to decrease? I have the black function f of t represents the rate that water is entering. The green function g of t represents the rate that water is leaving. If the water level is decreasing, what that means is I need water to be leaving faster than it's entering. Well, where does that happen? Let's look at it this way. At time t equals 0, there's the green function, there's the black function. Which one is greater? The green function. The green function remains greater, it remains higher until this intersection point at 1.617. So on this interval, t equals 0 to t equals 1.617, the water level is going to be decreasing. Starting at 1.617, the black function is taller than the green function. That means water enters faster than it leaves. Water level is increasing now. At time t equals 3, the green function is higher than the black one, which means water leaves faster than we're entering. So I'm going to be decreasing again. I'm going to continue decreasing until this next intersection point. And from this second intersection point all the way until t equals 7, water enters faster than it leaves, so the water level is increasing. So let's summarize this. When is the water level decreasing? Water level decreasing when g of t is greater than f of t. And now tell me the intervals where that happens. That starts happening at time 0, and it continues all the way until I hit my first intersection point. Then it happens starting at time 3, and it continues all the way until I reach the intersection point 5.076. And because I said specifically water level decreases when g is strictly greater than f of t, I want to make sure that I don't include the intersection point, because at the intersection point, the two functions are equal, and that's not satisfying what I've said here. So you would earn 1 point for indicating g of t greater than f of t, and 1 point for correctly indicating both intervals. So now we're up to 2 points. Not too bad. Now brace yourself for part C. Part C. Let's read the question. For the time interval 0 less than or equal to t less than or equal to 7, at what time is the amount of water in the tank greatest? That's right. Absolute max. To the nearest gallon, compute the amount of water at this time. All right, let's try this. Hopefully I can get this done before the 15 minutes is up. I want an absolute max. Well, first of all, we're looking for an absolute max on the time interval 0 less than or equal to t less than or equal to 7. Normally when we do this in class, the first thing that we do is we look for any relative maxima. A relative max is going to be where the water level changes from increasing to decreasing. Well, let's look at our graph. When does the water level change from increasing to decreasing? A lot of folks, myself included, when I first saw this problem, focused on the intersection points, because a lot of the problems that we've done, the intersection points are our candidates. Well, at the intersection point, the water level changed from decreasing to increasing. That's not a candidate for a relative max. This intersection point is a candidate for a relative minimum. How about this intersection point? Also changing from decreasing to increasing, so that's a candidate for a relative minimum. Does my graph ever change from increasing to decreasing? Yes, it does. Over here at time t equals 3, the water level was increasing. Now it's increasing. So my internal candidate is at time t equals 3. What I need to do now that I've got my internal candidate, we have our endpoints. The endpoints are t equals 0 and t equals 7. What I need to do is determine the amount of water that I have at each of these 3 places. Well, let's do it. At time t equals 0, the amount of water in the tank we were told is 5,000 gallons. That was our initial condition. Well, at time t equals 3, how much do we have? We have the 5,000 gallons plus however much we added during that time interval 0 to 3. That's the integral f of t dt. But we also have to keep in mind that we had water leaving the tank. And if we go back to the original problem, on the time interval 0 to 3, water was leaving the tank at a rate of 250 gallons per minute. So I'm going to say 5,000 plus the integral from 0 to 3 of f of t dt minus the integral from 0 to 3 of 250 dt. Just so that we're clear, this 5,000 is your initial value. This integral represents water added. This integral represents water leaving. Let's switch over to the calculator and see what this value is. We said 5,000 plus the integral, menu, calculus, integral. What just happened? Menu, calculus, integral, 0 to 3, f1 of x, integrate with respect to x, minus menu, calculus, numerical integral, 0 to 3, 250, integrate with respect to x. And according to my calculations, this is going to be approximately 5,126.591 gallons. We're doing well. Let me just go back to my notes. We know the amount of water at time 0. We know the amount of water at time 3. The last thing we need to do is figure out the amount of water at time 7. Well, that's not too hard. 5,000 plus the integral from 0 to 7, because now I'm adding water for a longer amount of time, minus, now this is where we need to be careful. I need to subtract the integral from 0 to 7 of g of t, the rate that the water is leaving the tank, but g of t is a piecewise function. And from 0 to 3, that rate is 250 gallons per hour. From the time interval 3 to 7, that rate is 2,000 gallons per hour. So I need 5,000 plus the integral from 0 to 7 of f of t dt minus this total over here. Because I'm running low on time, I'm going to cheat a little bit. And this is approximately 4,513.807 gallons. If you don't believe me, go to the calculator, type it in. To answer the question, we need to know, the question was, when is the amount of water in the tank greatest? Well, is that at time 0 where you have 5,000 gallons? At time 3 when it's 5,126 gallons? Or at time t equals 7 when you have 4,513 gallons? Clearly comparing those 3 values, we can see water level is greatest at t equals 3 hours. How much water is there? There will be 5,127 gallons, because again in this question we were asked to round. In terms of points, 1 point for identifying t equals 3, 1 point for having an integrand correct with the limits of integration anywhere in this analysis, 1 point for the amount of water at time 3, 1 point for the